What is this dielectric constant value? It is 2. So it can be written as K is equal to 2. The mass is the mass of the complete atoms or molecules which is present within that object. Whereas this weight is the one which is from the acceleration due to gravity. According to the sketching of the diagram, we will get to know which are the formula to be used in order to check the magnitude and direction. Hello everyone, I am Vrinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 4 of chapter 1, that is electric charges and fields. And today's concept is nothing but the numericals of the first chapter. Chapter is electric charges and fields. So here in today's class, let us deal with some sums which are very important when it comes to exam point of view, and from this chapter there is numericals which we'll have to study. So numericals of this chapter, that is the first numericals, what is it? 2 charges of 2 microcoulomb and 8 microcoulomb are separated by certain distance of 4 centimeters. So what are we supposed to do? We have to calculate the electrostatic force between them. So first of all, just write the given terms. What is given? 2 charges. Let one charge be named as Q1. 2 microcoulomb. The value of micro is into 10 to the power of minus 6 coulomb. Okay. And 8 microcoulomb. So second charge Q2 can be told as 8 into 10 to the power of minus 6 coulomb. So 2 microcoulomb is done. 8 microcoulomb is done. It is separated. So separation of this sideways, you can just draw the diagram which is needed here. That is, one charge is given here. There is a separation. This is the Q1 charge. And here there is presence of Q2 charge. So there are 2 charges, Q1 and Q2, separated by 4 centimeters. So this separation is 4 into 10 to the power of minus 2 meter. You're converting your centimeters to a standard unit, that is meters. Okay, the SI unit of measuring length is always meters. This we had studied earlier in the units and measurements chapter of your first PUC. Correct? So 4 into 10 to the power of minus 2 meter. You're converting centimeter to meter. Later, calculate the electrostatic force between them. So your F has to be calculated. Let me consider this as F1. If the distance between the charges is halved, that is, what is the distance between the charge? It is 4 centimeters. Half of the 4 centimeter is nothing but 2 centimeters. So suppose, so this will be the first case 1, and case 2, what are you supposed to do? You have to halve the distance, that is R is equal to 4 divided by 2. But here in this case, your R is completely 4 into 10 to the power of minus 2 meter. So R is equal to 4 by 2. Again, you will have 2 centimeters. So you can write your 2 centimeters as 2 into 10 to the power of minus 2 meter. Halved, and the medium of dielectric constant 2 is placed between them. So what is this dielectric constant value? It is 2. So it can be written as K is equal to 2. Dielectric constant is either given by an alphabetical term K or epsilon subscript R. So now later you have find the new electrostatic force. So new electrostatic force, let it be F2. This also you are supposed to find out, as well as find the change in force. Change in force means it is case 3. Let me consider this as case 3. So we have change in force given by delta F. So second force minus first force. So it is F2 minus F1 will be the formula for this condition. So we have to check case 1, case 2 as well as case 3. In order to proceed with the same numericals, let us just deal with the problems, that is having the formula, that is F is equal to 1 by 4 pi epsilon naught mod of Q1 into Q2 by R square. So let's deal with that. We have for case 1, this is the solution for us to start with. Force is a vector quantity, so F1 is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, or else we can also write F1 is equal to, this term can be written just as K into Q1 Q2 by R square. So on substituting for the values, K value 1 by 4 pi epsilon naught, this is not a dielectric constant, it is just the force constant. So K is nothing but 9 into 10 to the power of 9. Q1, what is the first charge Q1? 1 is 2 microcoulomb and 8 microcoulomb. So it can be written as 2 into 10 to the power of minus 6 into 8 into 10 to the power of minus 6 divided by what is R? The distance between two charges, R square. It can be written as 4 into 10 to the power of minus 2 the whole square. So on further solving, 9 into 10 to the power of 9. So multiply this with this, 8 into 2, it is 16 into 10 to the power of minus 6 plus minus 6. It is minus 12. So we have minus 12 divided by 4 square root is 16 into 10 to the power of 2 into 2, it is 4. So minus 4. Second cancel 16 with 16. So what are we left with? 9 into 10 to the power of 9 into 10 to the power of minus 12 into 10 to the power of, this goes up, so it becomes plus 4. So which is equal to 9 into 9 minus 12 plus 4 gives you 10 to the power of 1. So you have 10 raised to 1. So 9 into 10, it is 90. So it is a force what I am calculating. So F1 is 90 Newton. So that is all about your first force. Now the second one is like, so this is your case 1. By case 2, what are you having? It is like you have to find out the electrostatic force. You have got your constant Q1 Q2 by R square. So now this set of equation, what are we having? We have to elaborate this. So what is the value of K? Since we are considering this force in a medium, I can just consider this K as 1 by 4 pi epsilon and m. It is not in the free space, this is in the medium now. So Q1 Q2 by R square. As we know, the dielectric constant K is nothing but the ratio of epsilon m and epsilon naught. So epsilon m is equated as epsilon naught into K. So this equation can be written as F2 is equal to 1 by 4 pi epsilon naught into K and Q1 Q2 by R square. So you know what is the value of K? That is a dielectric constant. It is always said to be 2 in this question. So I can just equate this as, this can be written as 9 into 10 to the power of 9 divided by K value will be 2, and equating this, it is 2 into 10 to the power of minus 6 into 8 into 10 to the power of minus 6 and divided by, the distance is halved, so it is minus 2 the whole square. 2 into the 4, distance was 4 centimeters, it is divided, that is it is halved, that means it will become 2 centimeters, which is written as 2 into 10 to the power of minus 2 the whole square. Now we have F force is equal to 9 into 10 to the power of 9, and we have 16 into 10 to the power of minus 12 divided by 2 square is nothing but 4. 4 into 2 it is 8. I can write this as 8 into 10 to the power of minus 4, which is equal to 8 1 times, 9 2 times. So 9 into 2 it is 18 into 10 to the power of, I'll sum up all my powers, this as well as this, which goes up. So it becomes 10 raised to 9 minus 12. Since this goes to the numerator, it is plus 4, which becomes 18 into 10 to the power of 1, and you have your force given as 180 Newton. You have to remember, students, the SI unit is very much important, which carries 1 mark. So now we are having F1 with us and F2 with us. So what is the last question we had? That is a case 3. You have to find out the change, that is delta F, change in the force. So it is F2 minus F1. You get 180 Newton minus 90 Newton. So your answer is 90 Newton. So that is all about your question number 1, and you have found out electrostatic force when it is at distance 4 centimeters, electrostatic force when the distance is halved, along with that dielectric constant is induced, and finally it is change in the force. So case 1, case 2 and case 3 is over here. So here ends our first set of numericals. Now moving on to the second question. So let us read what is the second question. Second set of question is like, find the separation between two protons in order that the electrostatic repulsive force which is acting on either of them will be equal to its weight. Okay. So what is the charge of the proton? It is 1.6 into 10 to the power of minus 19 coulomb, and mass of the proton is 1.67 into 10 to the power of minus 27 kg. Okay, so this is the set of questions what are we having. Now, the thing is, now we have to check the distance of separation in the question. That is, find the separation between two protons. So what are we having? It is given. In given we have distance of separation has to be found out. So we don't know this. So R is a question mark. In order that the electrostatic repulsive force acting on either of them is equal to its weight. So we don't know what is weight, but we have mass of the proton. Remember, I had told you the mass is different and the weight is different. Mass is the mass of the complete atoms or molecules which is present within that object, whereas this weight is the one which is from the acceleration due to gravity. So now it is like mass, that is the weight of the proton. How can it be calculated? That is our question. Given mass is given, which is equal to 1.67 into 10 to the power of minus 27 kg, and the charge of the proton is given, which is equal to 1.6 into 10 to the power of minus 19 coulomb. Okay, so these are the given terms. Now dealing with the question, here we have got, let me consider this as case 1, where you have to calculate weight of the proton. In order to calculate weight of the proton, what are you supposed to do? Mass into, that is weight is equal to mass into acceleration due to gravity gives you weight, okay, which is equal to, what is its mass? It is 1.67 into 10 to the power of minus 27 kg, and multiply this with 9.8 meter per second square. Okay, which is called as acceleration due to gravity. So what are we left with? So we are left with 16 point, the value will be 16.366 into 10 to the power of minus 27. just shift your decimal place, so it becomes 1.64 into 10 to the power of minus 26. Its weight what we are calculating, so it becomes Newton. Okay, so it is called as Newton. Now we have got the weight of the proton, and in question they told the weight of the proton is equal to the electrostatic force. Then we have to calculate the distance of separation. So we know that if you just consider case 2, we have the formula, that is electrostatic force is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. What is electrostatic force? It is nothing but the weight. So this can also be called as the force. Okay. So we have to calculate R. So you can just take your R that side and your force towards the other side. So equation becomes 1.64 into 10 to the power of minus 26 Newton is equal to, what is the value of this? That is 1 divided by 4 pi epsilon naught. It is 9 into 10 to the power of 9 into the two charges, that is the proton, and the proton is having a charge of 1.6 into 10 to the power of minus 19 into 1.6 into 10 to the power of minus 19. That is why I'll square it there and then itself. Okay, and divided by R square is the unknown term. So take your R square towards the left hand side. So we are having 10 to the power of 9 into 1.6 into 10 to the power of minus 19 the whole square divided by 1.64 into 10 to the power of minus 26. So we have got this simplified format. So now we have on solving, that is 9 into 10 to the power of 9, you remain as it is. 1.6 into 1.6, it is 2.56 into 10 to the power of 19 into 2, it is minus 38, and divided by 1.64 into 10 raised to minus 26. So having these many, we have to calculate, that is simplify further. You have got 9 into 2.56. So 9 into 2.56, it can be written as 23.04 divided by 1.64. Take your roots, everything, that is to the power of, it's not roots, it's to the power of. Okay, 10 into 10 raised to 9 into 10 raised to minus 38 into 10 raised to, when it goes to numerator it becomes plus, it is 26. So what are we left with is equal to, it becomes 14.04 into 10 to the power of minus 3 is your R square. So you can just write R is equal to, just shift the decimal so that minus 3 cancels. When you shift the decimal places towards the right hand side, when you just turn towards your board, your right hand side is always negative and your left hand side is always positive in case of the decimal places. So when you just take your decimal point from this position to the other, that is towards your LHS, it can be 1, 2 and 3. So it is 0.014 is the R value. So our root of 0.014. So this is R square and you're finding out R. So you have R is equal to 0.118 meter. So this is the separation of two protons. So that is all about your second question. So here, this is a way of writing the numericals. That is, first of all, you will write the given terms. Then you will have to go on with the solutions by solving for case, like case 1, case 2, case 3, like this. Step by step, each steps you have to do it without fail, as well as you have to get a correct answer along with the SI unit. So I hope this is very easy for you now. Now let us move to the third question. That is like, the third question is, two fixed point charges, 4 microcoulomb and 1 microcoulomb, both are separated by 30 centimeters in air. Find the position between them at which the resultant electric field is said to be 0. So now let me just consider the given terms. What are given terms now? Two fixed point charges, that is, let Q1 be 4 micro, means it is minus 6 coulomb. Q2 be 1 into 10 to the power of minus 6 coulomb. These are separated by a distance of 30 centimeter, but we have to convert it to meter. When that is the case, it is 30 into 10 to the power of minus 2 meter. Find the position between them, that is the distance of separation. Midway, we have to find a point where exactly the electric field becomes 0. So, position, in order to find out position, we don't know what is x, so calculate that x. So now diagram is two charges are there which is separated by certain distance. So charge Q1 is 4 microcoulomb and charge Q2 is 1 microcoulomb, which is separated by a distance of 30 centimeters. Okay, and find the position between them. See this word between them, that means midway between those two. We don't know, some position is present over there, that is a rough sketch where exactly your electric field E is said to be 0. So this distance we don't know, so it can be considered as x distance, and from here to here it can be considered as 30 minus x, or else it can also be considered in meters as 0.3 minus x. So this is the value. Now having this concept, we will have to go further, that is, we have to find out mid length of this diagram where exactly the total electric field is said to be 0. So now having this, let us just equate two sets of equation, that is, one when the distance is at x and the other one when the distance of separation is 0.3 minus x. So we have two set of equation. Just write down, that is, it is a solution. Let P be a point between two charges where the electric field is 0. So I can just remodify the diagram of writing this point as P. So this can be A and this can be B. A, B, and the middle point is said to be P. So now we can write this equation as like equate two electric field due to two charges given as E from first charge is equal to electric field E due to second charge. It is K, that is 1 by 4 pi epsilon naught is present here in this only one alphabet, that is K. K into Q1 divided by X is equal to K into Q2 divided by 0.3 minus X. Both of them you're supposed to square due to the formula. So now your K gets cancelled with K. So what remains is Q1 by X square is equal to Q2 by 0.3 minus X the whole square. So what is your value of Q1? Q1 is 4 microcoulomb, which is equal to Q2 is 1 microcoulomb divided by x square divided by 0.3 minus x the whole square. So again your power cancels, 10 raised to minus 6 cancels with 10 raised to minus 6. So what remains is 4 by x square is equal to 1 by 0.3 minus x the whole square. So on cross multiplication, this goes with this and this goes with this. So we have got 4 into 0.3 minus x the whole square, which is equal to x square. On taking roots on both the sides, we have 2 into 0.3 minus x is equal to x, because square root cancels with square and root of 4 is always 2. And now we have on multiplication with the 2 into 0.3 gives you 0.6 minus 2x is equal to x. So your 0.6 remains as it is and your minus 2x goes to the other side. So it becomes x plus 2x. There is change of sign. So minus 0.6 and 2x plus x is 3x. So your x is equal to 0.6 divided by 3. So you have x is equal to 0. And it is 2. So it is 0.2 meters or 20 centimeters. This is your answer. That is at point P, the distance from A to B, midway it is P, and that distance where exactly your electric field is 0 is said to be 20 centimeters or 0.2 meters. So this is all about your third set of numerical solution. And next, moving on to the fourth set, it is like two positive charges, 9 nanocoulomb and 4 nanocoulomb. There are two positive charges, 9 nanocoulomb and 4 nanocoulomb, which is placed at points A and C respectively. It is placed at the points A and C of a right angle triangle ABC. So B is at the center where angle B is nothing but 90 degree. AB is said to be 3 centimeters. BC is said to be 2 centimeters. So what are we supposed to do? We have to find the magnitude and direction of the resultant electric field at B. Okay, so now finding out magnitude and finding out direction, let us just sketch the diagram how exactly it looks. According to the sketching of the diagram, we will get to know which are the formula to be used in order to check the magnitude and direction. So write the given terms now. Given two positive charges. So Q1 is also positive, 9, Q2 is also positive, it is 4. It is N, small letter N means it is nano. Okay, nano coulomb is 10 raised to minus 9. Nano means it is 10 to the power of minus 9 coulomb, and 4 into 10 to the power of minus 9 coulomb. So we have two sets of coulomb, 9 into 10 to the power of minus 9 and 4 into 10 raised to minus 9. It is placed at point A and C respectively of a right angle triangle. So now suppose if this is your right angle triangle, let me name it as A, B and C. So this angle is at 90 degree. So A is 9 nanocoulomb and point C it is 4 nanocoulomb. So we have B as 90 degree. AB is said to be 3 centimeters. Okay, so AB is 3 centimeters. Your BC is, B and C is 2 centimeters. Find the magnitude and direction of the resultant electric field at B. So B, so the force which is acting from this charge which is placed at point A is, that is the electric field is given in this direction. Name it as E1 vector, and due to charge 4 nanocoulomb there is a electric field in this direction vertically downwards, so it can be called as vector E2, and the resultant force is always in this diagonal manner, so it is called as vector E. So this forms something like parallelogram law of vector addition. So in order to find out magnitude as well as direction, it is our responsibility to take up parallelogram law of vector additions formulas, that is tan formula, as well as root formula, that is the resultant vector. R is equal to root of a square plus b square plus 2ab cos theta. That is how we identify the resultant electric field. So now we will have to check out what is E1 first, what is E2 first. Only if you have E1 and E2 you can go up with the total electric field, that is E. So first case, second case, third case and fourth case. So here there are 4 cases. Why? Because case 1, let us identify electric field at point E1. Case 2, let us identify electric point at E2. Case 3, let us identify the total electric field by using root of a square plus b square plus 2ab cos theta equation. And case 4, let us identify direction. Okay, so there are 4 cases for us to solve now. So first of all, let us go with electric field, that is E vector 1 is equal to K mod Q1 by R square. So it is 9 into 10 to the power of 9 and your Q1 is 9 nano coulomb divided by the distance of separation, that is A. From A to B, the distance is 3 centimeters. So it is 3 into 10 to the power of minus 2 the whole square. So what is the answer? It is 9 into 9, it is 81 divided by 3 twice, it is 9 into 10 to the power of 9 minus 9 and it is minus 4. Here it is minus 4. When it comes to the numerator, it becomes plus 4. So it is 9 one time, 9 9s are 81. So it is 9 into your 9 cancels with 9. So what remains is 10 to the power of 4. So your E1 is 9 into 10 to the power of 4 Newton. So this is all about your first case. Let me consider this as case 1 and the case 1 is solved. Next is case 2. What are you supposed to do in case 2? It is just that you will have to calculate in the same manner. E2 is K into mod of Q2 divided by R square. It becomes K is 9 into 10 to the power of 9. And what is Q2? It is the charge known as 4 into nanocoulomb means to the power of 9 divided by R square is nothing but 2 into 10 to the power of minus 2 the whole square. Minus 2 because it was in centimeter, you have converted it to meter. So which is equal to 9 into 4, it is 36 divided by 2 double times, it is 4 into 10 to the power of 9 minus 9 and this is minus 2, it is 4. When it goes up, minus 4 becomes plus 4. So it is just 4. So 4 ones are 4, 9s are 36. So 9 into 10 to the power of 4 Newton will be your second set of the electric field. Okay, so you got to know E1 as well as E2, so both are solved. After getting your E1 and E2, what is your work? It is you have to find out the total electric field. So in order to find out the total electric field, you have got vector E. This can be called as case 3 which has to be solved. Total electric field is nothing but root of E1 square plus E2 square plus 2E1 E2 cos theta. So since theta is equal to 90 degree, cos theta is equal to cos 90, which is 0, as you know the trigonometric condition. So cos 90 is 0. Then the whole term cancels to 0. So now we have total electric field vector E is root of E1 vector square plus E2 vector square, and it is 0. So now we have what is E1 value and E2 value. It is root of 9 into 10 to the power of 4 into 9 into 10 to the power of 4, and this is vector E. So it is square of both the equations and positive in between. So we have vector E is equal to root of 9 double times, it is 81 into 10 to the power of 4, 2s are 8, plus 81 into 10 to the power of 4, 2s are 8. And on solving this, you have got 81 plus 81, it is 162 into 10 to the power of 8 is which is a common term, and this is vector E, and total of vector E, that is root of 162 into 10 to the power of 8 is nothing but 12.72 into 10 to the power of 4. That is just because you are root of 162 is nothing but 12.72, and root of 10 raised to 8 can be equated as 10 to the power of 8 the whole 1 by 2, and 10 to the power of 8 the whole 1 by 2 is calculated as 2 1s are, 2 4s are, so what remains is 10 to the power of 4. So here this is what we are getting. So this is said to be the magnitude of the electric field at point B, that is at this point the electric field E is present, that is along this line B to E. Okay, so here we have magnitude at that point is 12.72 into 10 to the power of 4, and the SI unit is Newton Coulomb inverse, wherein here you have got Newton Coulomb inverse and Coulomb inverse. This is Newton Coulomb inverse, and for force it is only Newton. After which we have to identify the direction. In order to identify the direction, we just considered our case 4. So how to go on with case 4? You know that tan theta is equal to A sin theta plus B plus A sin theta divided by B plus A cos theta. So what is A? This is A, this is B. A sin theta divided by B plus A cos theta. So write E1 sin theta divided by E2 plus E1 cos theta. Theta is always 90 degrees, so cos 90 is said to be 0. So this term cancels out. So what remains is tan theta is equal to E1 into sin theta. So sin 90 is 1. So what remains is just E1 with us. So E1 is what? 9 into 10 to the power of 4 divided by what is E2? Again it is 9 into 10 to the power of 4. Both cancel, so it is 1. Tan theta is equal to 1. So take your tan to the other side. So theta is equal to tan inverse of 1 is nothing but your 45 degree. So the direction of the resultant electric field at B is nothing but 45 degree. Then you can just mention, since it is 90 degree, it is correct half of it, that is it is at 45 degree. So you have found out your magnitude and the direction of the resultant electric field, and 5 marks will be in your pocket if you solve this kind of questions in this manner. See, it's very neat manner, that is first write given, diagram, case 1, case 2, case 3 and case 4. All the set of solution just for question number 4 is given in a one single slide over here. So it's very easy for you to understand as well. So in the instruction in the question paper, it is clearly given direct answer without solving, not carry any marks. Got it? So that is all about your question number 4. Now moving on to question number 5, you have got a positive charge of plus microcoulomb is placed 1 meter away from a similar negative charge. So there are two types of charges. One is positive charge and one is negative charge. What are we supposed to do? Calculate the electric field at a point 1 meter away from each charge. So write given a positive charge is Q is 10 microcoulomb, which can be written as 10 into 10 to the power of minus 6 coulomb, is placed 1 meter away. So distance R is said to be 1 meter. Okay, there is no conversion here because meter is always there. It is like centimeters, then we have to convert it. For a similar negative charge, that is minus Q, this is plus Q and this is minus Q, will be 10 microcoulomb. So you can just write it as 10 into 10 to the power of minus 6 coulomb. We will have to calculate the electric field at a point 1 meter, which is away from each of the charges. So there is two charges, plus Q and minus Q, plus Q and minus Q. So the negative charge is also of the same value. So I'm just writing 10 and 10 as it is over here. So now the negative charge consists of minus, but since for the electric field there is a magnitude condition, it cancels out. So it is 10 and 10 as it is. Instead of putting minus, you can just take it as 10. So now plus Q and minus Q are present over here. We have to calculate the electric field at some point which is at 1 meter away from both the charges. So when that is the case, usually in this chapter we have studied regarding the equilateral triangle. So here there is some point which we don't know. Consider this as A, this as B and this as C, which is 1 meter away from both the charges. Okay, so at C, we have to calculate the electric field at that point. Okay, so this produces certain electric field called as E1, and here there is a production of E2, and here there is your resultant vector, which is making a parallelogram law of vector addition condition for you. Okay, now calculate the electric field, that is E, at point C. So we don't know this sector. Here there is nothing that you have to identify the direction. It is only they have asked you to calculate the magnitude here. So now since the two charges, that is this is also same and this is also same, E1, Q1 is same as that of E. So now we have got two similar charges, Q1 and Q2. Only the signs are different, because of which we can just collaborate E1 and E2 given as K into Q divided by R square. It can be either Q1 or else Q2, because the value is same. Instead of wasting my time in writing E1 separately, E2 separately, both of them are having one and the same equation. You can separate it, writing E1 is equal to K into Q divided by R square, and solve for that, and write E2 is equal to K into Q2 divided by R square. Okay, so now here you have K value as 9 into 10 to the power of 9, and Q charge can be 10 into 10 to the power of minus 6 divided by, what is this, R square? R square is the distance of separation, that is 1. So here you can calculate it as 9 into 10, it is 90 into 10 to the power of 9 minus 6. So you have got 90 into 10 to the power of 9 minus 6, it is 3. So just to take 1 point the other side, shifting 1 point towards your left hand side, you get 9 into 10 to the power of 4 Newton Coulomb inverse, which is the value of E1 as well as E2. For both also it's the same value, only because the charge is a similar one with different sign, that's all. Other than that, if it was different charges, then you will have to solve for each step, for E1 also separate and E2 also separate. Now your work is to solve for the parallelogram law of vector addition formula. That is, you have got R is equal to root of A square plus B square plus 2AB cos theta. We don't know what is theta. Remember always, for an equilateral triangle, the angle theta, equilateral triangle, the angle theta is always 120 degree. So cos 120 degree is nothing but minus 1 by 2 according to your trigonometric conditions. Okay. So now you have got your a square can be rewritten as e1 square plus the e2 square plus 2 into e1, e2 and cos theta is that you can just write directly as minus 1 by 2, which is equal to, what is your e1? It is 9 into 10 to the power of 4 the whole square plus 9 into 10 to the power of 4 the whole square and 2 into 9 into 10 to the power of 4 into 9 into 10 to the power of 4 and minus 1 by 2. This can be written as, so now here you can just write, I'll rewrite this, 4 the whole square plus 9 into 10 to the power of 4 the whole square and here it is plus 2 into 9 and 9, it is 9 into 10 to the power of 4 and into 9 into 10 to the power of 4, I can just write this as 4 the whole square and into 1 by 2. So square root cancels with this root cancels with this and this cancels with this. So we are left with, on solving that, we have 9 into 10 to the power of 4 plus 9 into 10 to the power of 4 was remaining. So it is 18 into 10 to the power of 4 plus root lies only for 2 and we have 9 into 10 to the power of 4 and here it is minus 1 by 2. On simplifying this by using your calculators, finally you will end up with 9 into 10 to the power of 4, which is called as the resultant vector, that is the electric field, and it is given by Newton Coulomb inverse, and here ends your question number 5. So this is how you solve. First of all, write given terms, sort out which are there and which are not there, write the respective diagrams for the same question, that is imaginary concept is very important when you solve up the numericals. So imagine the concepts, draw certain diagrams so you will get to know along which side your electric field is flowing and along which side your electric field, first electric field, second electric field and the resultant electric field is flowing and which is the direction it is taking. All those things comes only when you have got your imagination power. So now this is all about your first, second, third, fourth, fifth, 5 numerical problems are being solved under this chapter, that is chapter 1, electric charges and fields. So in today's class you have studied the numerical problems of the chapter 1, that is electric charges and fields. So there were 5 numerical problems which was discussed here. So now you will be getting same set of questions or similar to this set of questions wherein the solving problems, that is the solutions will be one and the same, like literally in the same manner. Okay, so I want you people to get back and recheck the numericals as well as study those numericals, grab few questions and solve these questions. So now let us all meet in our next class with the upcoming session of the chapter 2. Until then, have a good day. Thank you.